My name is John Kanzita. Today I'll be talking about something that we hear about all the time, but very few people know anything about, and that's AI. So, over the years, development in technology has advanced the physician's role in patient care. For instance, the stethoscope enhanced their hearing, and MRI enhanced their vision, allowing us to diagnose diseases that were previously hidden. However, the advent of AI has left many physicians anxious because, quite frankly, it seems to be after our jobs. My hypothesis, though, is that if healthcare providers are more familiar with how AI works, we can harness it to improve patient care, just like the stethoscope or MRI. Like any tool, we just need to understand how to use it. Except pathologists. They probably pay close attention to this presentation. Just kidding. So today I'd like to answer 3 questions. First, how do machines learn? And we'll explore this through a case study. Second, how can we apply this technology in medicine? And third, what does it mean for us? The most important one. But first, let's talk about how machines learn. So say hypothetically that you'd somehow never seen an ice cream cone before. And I told you there was an ice cream cone somewhere in this image. And this one. And this one too. Well, after enough images, you realize that a common pattern besides the aviator glasses is a triangle with a circle on top. And that's correct. So using this pattern, we can look at any image and determine whether an ice cream cone is present. Well, let's break that down. How did we do it? Well, we know from algebra, that we can take an input, pass it through a function, transform it into an output. And f of x is simply the pattern that relates our input and our output. In our case, the images were the input, and the output was our decision on whether an ice cream cone was present. Now, both of these were provided, so what we had to learn was the pattern that related the two, specifically the presence of the shape. So how can a computer do the same thing? Well, this problem is solved by machine learning, which is the process whereby a computer learns a pattern. And there are many types of machine learning, but they all follow the same 3 steps. First, we have no idea what we're looking for, so we start with a guess. Second, we just pass some data through our function and see what comes out. Next, we see whether the output matches our expectation of what it should be, and use this information to update the guess. And by repeating this process thousands of times, our initial guess of the pattern becomes more and more accurate. It's essentially guessing and checking. So let's use this process to teach a computer to recognize an ice cream cone. All we need is a mathematical model that can learn any complex pattern. And it sounds really complicated, but let's start simple. So how could a computer solve for the slope in the linear equation y equals mx? I bet you didn't know there'd be some math today. First, let's just visualize this equation. So as before, f of x is a pattern that relates our input and our output. Right now, we have no clue what it is. So we'll need some help. So we tell the computer that for this particular pattern, when the input is 1, the output is 5. And we're all very smart, so we already know that the slope is 5, but the computer's kind of dumb. So it starts with a guess, in this case 1. And when we pass these values through our function, the output is 1 times 1, which is 1, and that's lower than the value we're looking for. So the computer's guess was too low. However, by using this information to update the guess, the computer eventually converges on the correct pattern by guessing and checking. And this process of updating the guess is exactly how computers learn. So essentially what we built is a pattern recognizer that can simple linear relationships. And this is very useful, so let's just use the notation that's actually used in the industry. It's the same thing, but just a lot prettier. And so the second thing to note is that instead of slope, we call m the weight. And as we saw, this is the parameter we need to learn. In engineering terminology, we call this linear pattern recognizer a neuron. And the reason why brings me to my most important point. So when we make a mistake, say going to Taco Bell, our brain learns by altering the connections between millions of biological neurons. So what if we took inspiration from this and connected several of our pattern recognizers together? Well, presumably we could learn more complex patterns, but let's see what happens when we try. So for instance, we can add inputs to our neuron, we can assemble it into wider networks, we can assemble it into deeper networks. As we can see, the more complicated our networks get, the more connections or weights we have. And the more weights we have, the more complex patterns we can learn. And to see why, if you're a visual learner, hopefully this will help. If you have just one parameter, you can only describe a line. If you have 2 parameters, you can describe a square. With 3, you can describe a cube. And by altering their values, you can represent any shape imaginable. So by extension, the more parameters our network has, the more complexity we can represent. And so it's easy to see why engineers call these neurons. So just like biological neurons represent information by altering connections, our brains learn by altering connections between biological neurons, our computers learn by altering connections between computational neurons. So it's easy to see why these networks are called neural networks. They're the most medically relevant machine learning model, very high yield, and we'll see why in a second. So let's teach our computer to recognize an ice cream cone. And as before, it doesn't know what an ice cream cone looks like, so it starts with a guess, in this case a rectangle. Now I'm showing you this pattern visually, but in reality it's encoded into the weights of the network like we just showed. And of course at first our computer's dumb. So when we input our first image, the output's not what we're looking for. But again, we provide both the input and the output. So we tell the computer that there's an ice cream cone present in this image. And after thousands of iterations, the computer uses this feedback to update the guess until the pattern starts to look more familiar and the output begins to match what we're looking for. So as we can see over time, the computer eventually learns the characteristics of an ice cream cone by searching through images to find a pattern. And the process of using neural networks in this way is what you might have heard as deep learning. So all that's great, but what does it mean for medicine? So what if instead of Joe Biden photos, we pass through images of squamous cell carcinoma? Well, following the same process, we guess to the patterns we're looking for, and use the feedback over thousands of iterations to update the guess to what we're looking for. And so over time, the computer may learn to search the image for a pearl-shaped pattern, thus learning the diagnostic indicator, keratin pearl, or squamous cell carcinoma, of course. So then we could use the same network to diagnose squamous cell carcinoma in other samples. And this method has been proven so effective that it's been shown to surpass human ability. So the reason I chose to discuss neural networks is that they're useful for any pattern recognition problem in medicine, from the artificial pancreas to the cool EKG app. For instance, instead of analyzing image data, we can analyze ECG data for cardiac monitoring, data from cancer studies being used to personalize chemotherapy treatments. Epidemiological data is used for disease outbreak prediction, and they're even being used for adverse event prediction in Parkinson's patients. Now, this is a personal research area of mine, which just goes to show you that anybody can work with computers. So finally, thank you. Finally, and most importantly, what does this mean for us? Well, actually, the future doesn't look bleak at all. In the future, AI won't replace physicians, but it will augment the role in patient care, just like the stethoscope or the MRI has in the past. The stethoscope enhanced their hearing, the MRI enhanced their vision, and soon AI will enhance their diagnostics and treatments. And this applies to any specialty, from pathology to whatever it is Dr. House does. All it requires is a basic appreciation for how AI works, and I hope I provided that to you today. So thank you very much.